Okay, welcome back. This is part 2 of the video, and the first one didn't want to get it to go too long, but what we did on the part 1 video, if you were not there, is that we showed how to set up the free body diagram of a block on an inclined plane. We talked about what it means to rearrange the axis, meaning defining which way is up and down to help us eliminate the angles and also give us only one acceleration. We set up the equation enough for you to plug it in and figure that out. So part 2 is the same scenario. It's a chunk of ice that's sliding down, but instead of sliding down and to the right, it's now sliding down the other side. So if we imagine that we had a house here, okay, we looked at the chunk going down this way. Now we're going to look at the chunk going down this way. You may say, well, isn't that the same thing? It is the same scenario, but how we write our equations is going to be a little bit different because you will see here, because the friction is going the other direction. So to solve for the same scenario as number 1, but instead have the chunk of ice, same chunk of ice, sliding down the other side of the roof, which is at an angle of 40 degrees, so same angle. But now has a rougher surface due to the roof facing the sun, and snow has melted for some reason, okay? And now mu is 0.6. Okay, so we're just going to set up the equation with the variables, and then you can plug it in. And then same thing. You're also going to figure out how fast it's going. You should probably expect it should be going not as fast if there's more friction, but we'll get to that here. So whereas in the first one we had this sort of setup, okay, and this one, number 1, and in number 2, now we have it going in the opposite direction. Okay, it's not more steeper. I'm sorry if I drew it more steeper, but it's not more. It's not. It's the same steepness. So this angle there. So like I said, it helps to actually, like you're plucking this off to the side, draw this at the angle there. Okay, so we're imagining there. Draw the same forces we have. So if you say, hey, this is going too fast, go back to part 1. Go through this a lot slower. So force of gravity, remember that it now is moving in this direction. So we have normal force that is now going perpendicular to the surface and outward this way. And because it's moving in this direction here, the force of friction is now in the opposite direction, parallel. So as we stated in number 1, so we do have an acceleration here. As we stated in number 1, we are going to redefine the axis here. Okay, we're redefining which way is which. And I know how we do this is a little bit different from other classes here in terms of that. But we're going to redefine it here. We're basically going to say that if this is the y-axis here, and that is the x-axis, so we're defining that to be the positive y. And to be consistent with what we're doing up to this point, we are going to continue calling the right positive x. So we'll continue. There are some classes that say whatever direction the object's moving, make that positive. I think that's a little confusing for introductory level, so we will keep saying that this way is the right and that's positive. So this is right, and then this is up. So we have to also draw our components on this. And so remember that this is the hypotenuse. This is the hypotenuse. We have to create a triangle, a right triangle, that will allow us to show the force of gravity is the hypotenuse here. So if this is my y direction, I go down. Don't worry about that. It's my prep period. I'm never there. So that is the f of g of y. That's the component in the y direction. And instead of going to the right, we have to connect here. So we are going to have that back there, and that's fg of x. And then similarly, this angle of incline is this angle right there. Okay, it's not hard to see. So that is that angle right there. That angle is that angle right there. And that's all we have. However, we have to be a little bit cautious here because I said the acceleration is this way. And if I want to be correct, okay, I'm going to do right minus left. I can't call this a positive acceleration. I can't say that it's going to the left and leave this as a positive number, because a positive number, if we go back to the other side, a positive number means it's moving to the right, and that's not what's happening. It's now moving to the left. So to correctly do this, and this is the key where people usually get caught up here, is that we need to make that a negative number, a negative acceleration, and we're just going to put a negative in front of it. And we're also realizing that that is also in the x direction, which is helpful because a of y is now 0. So if it's moving, and based on this, if it's moving up the ramp, a of x would be positive, and for this example. Or let's just say if it's moving in the positive x direction, we need to say a of x is positive. We're moving in the negative direction, a of y is negative. Okay, so the reason why we made it positive on this side, I guess positive a of x on this side, is because how we define positive x, it was moving in that direction. Okay, sorry, back over here. Hey, and that is our free body diagram. And so I know we're not used to usually subtracting the force of friction. If I go back to the other side real quick, sorry. We're used to saying some force minus the force of friction, but the reason we did that is because we were defining we were basically always moving in the right direction where force of friction was left. So here, when we write some of our forces in the x direction, okay, we need to literally look at the free body diagram, what it's saying. Remember that this direction is now right. We always do right minus left. Okay, this direction is right, so we have force of friction to the right. All the forces to the left, so maybe cancel Fg because we have to use Fg of x. So right minus left, Fg of x is now being subtracted, equals m. And I said, well, that's the reverse of what we did, but remember, in order to compensate for that, we also say that this is negative a of x. Because it's going down. It's not going down, sorry, it's moving in the left direction. So let's simplify this a little bit. F of f minus fg of x. So let's go back here and say, okay, which one is it connected to? It's still connected to the y-axis, so that's going to get cosine. And that means that's going to get sine. Okay, so f of g is mg. The x component of that is going to get sine. And a little bit easier way, instead of thinking m times negative a of x, you can just write it as negative m a of x, if it's easier to do that rather than solving that around. Okay. So that would be our equation in that direction. Similarly, if we think about what we're given mass, we're given gravity, we're given theta, and we're given mass. So just you really solve it algebraically. We don't have enough information here, but that is based on the free body diagram. Okay, we now look in the y direction, and we actually should see that it's it's the same here because we flipped which way this block was going down. But we have up, we have normal forces up minus all our forces down. So not force of gravity. That's why I like when I draw that. I like to kind of cross it out so I don't do that. This is up minus f of g of y. Okay, that's all the forces we have up or down, equals m times a of y. And because we reoriented our axis so that this is positive x, this block is moving completely horizontally, which means that a of y is 0, which means that side goes to 0. Or f of n minus mg, mgy, so that's connected to the theta is connected to that, so that's when we get cosine of theta, and that equals 0. And once again, this is our equation. And what are we given? We're given mass, gravity, and theta, so it's very similar to solve there. It's just this is written in a little bit different direction. We still have the coefficient of friction here. We still have the normal force. So you can plug that into there, solve for that, and plug that over there to solve for a of x. Okay, so I guess if we're saying the biggest lessons in today for this one is understanding how to draw this triangle, realizing that these two components have to make up the perpendicular side of the triangle. A common mistake, okay, if we go to mistake corner over here, okay, common mistakes. If I can spell common, there we go, is that when they have FG this way, so let's say that that's our box or something like that, they have FG that way, a common mistake is to draw it like this, where they have that FG of y, and then they have this somehow back to here, FG of x. Notice these two have to be perpendicular to each other. This is not a correct free body diagram for this. And why that would be, well, just in terms of how all that would work, it doesn't line up. Because if we think about how we're, it doesn't even make sense because if you look at this, if this is our y, sorry, I'm off camera here. Let me go back to that. Mistake corner down here. Okay. So a common mistake is drawing the force of gravity this way, which is correct, but drawing the FG of y as the hypotenuse and the FG of x as the other corner. That doesn't even make sense because if you see here, FG of y is not on the y-axis, so you can't just subtract it down, and FG of x is not completely there either. So you have to realize that for this object here, that if this is our x-axis and this is our y-axis, it makes sense that our y would be along there, here, and our x would be along, that's not the best one, it would be along there. So that's it. So the common mistake is drawing these as one of the hypotenuses here. So you go back to here saying these have to be aligned. Notice FG of y is in the same line as as the y-axis, and FG of x is parallel to this one as well. So I'm going to go in also at the end, you're going to have to solve for delta x, or sorry, not delta x, you're going to solve for the final velocity. It's the same length of the root, but you should see that the acceleration should be less. There's more friction, it should be less, and then you'll solve for the final velocity. That will help so you don't have to do so much review when you get to the final. So I'm going to go ahead and pause that. This should be enough for you to figure out what the answers are or how to get that. If you have any questions, message me on Schoology. We're going to end this second video. I'll see you another time. Thanks.